This sign is known all over the world as the hazard symbol for radioactivity. The radiation emitted from a radioactive source is invisible, but a Geiger-Müller tube attached to a counter can detect its presence. The greater the number of clicks, the higher the level of radiation. Remove the radioactive source and the count falls, but it doesn't drop to zero. Wherever you are, there's always a low level of so-called background radiation. Whether you're out in the street, in the middle of the countryside, even inside your home, a Geiger counter continues to detect low levels of background radiation. That's because all sorts of materials are naturally radioactive. This rock contains the element uranium. Even this wall tile is emitting radiation. And just listen to this old watch. The luminous paint on its hands contains the radioactive element radium. This is the amount of potassium chloride in an average human being. A small percentage is radioactive. Cosmic rays reaching us from outer space also contribute to the general level of background radiation. To understand what radiation is, you have to go back to the basic structure of an atom. All atoms have a nucleus made of neutrons and protons. Surrounding it are electrons. The nucleus of a radioactive atom is unstable. It can break up at any time, emitting radiation as a result. But because we can't see nuclear radiation, it was only discovered just over 100 years ago. A French scientist called Henri Becquerel accidentally found out that the invisible radiation from a rock affected a photographic plate. We can mimic Becquerel's discovery using a piece of film in a light-tight container and placing our radioactive objects on top. Once the photographic film has been developed, you can see the marks the radioactivity has left behind. A cloud chamber also makes the effect of some nuclear radiation visible. The chamber contains air saturated with alcohol vapor. The metal disc in the middle is a radioactive alpha source. As the radiation shoots through the alcohol, it leaves behind a vapor trail. That's because nuclear radiation ionizes air. When the radiation collides with atoms in the air, it dislodges electrons. These air particles become positively charged ions. As the radiation passes through the air in the chamber, it leaves a trail of positive ions behind. The surrounding alcohol molecules condense on these ions to form a trail of tiny droplets. In this way, the path taken by the radiation becomes visible.